What is a parametric equation of a line and how do we calculate it? In 2 dimensions, lines are described by a point and a slope, something like y equals mx plus b. But sometimes we'll write it with y minus y1 equals m times x minus x1. In 3 dimensions, we no longer describe them that way. We describe them by some sort of point and a parallel vector. So from this, we say slope doesn't really mean anything in 3 dimensions. We can't do change in z over change in y over change in x like we do in 2 dimensions. So we have to describe it by a vector. So if a line starts at P, and it doesn't necessarily have to be like the origin, it just has to be going through that point, and is parallel to a vector v, each point is a scalar multiple of v away from P. So if I multiply v by a half and add it to P, I get to this point. If I multiply v by 2 and then add it to P, I get to this point. If I multiply by some negative number and add it to P, I get this point. And every point along this line is some multiple of v away from P. This is a little bit hard to see in 3 dimensions, but I can show you a really good demonstration in 2 dimensions. Here I have a vector v, and here's my point P that I'm starting with. So I'll start with this point P and this vector v, and what you'll see is this point P is a scalar multiple away. Specifically, it's 1 times v away. But if I change what I multiplied it by, here you see t, I'm changing the value of what it's multiplying by. You'll notice that this point is traveling along a line as I multiply the value of v. So here's my vector v that it's parallel to, and all the points on this line are described by some scalar multiple of v away from P. And if I change v, now it describes a different line. If I change P, now it describes a different line with the same direction. So essentially P is describing where it starts, and the vector v is describing what direction it's in. So we're doing this type of drawing through it. So t is going to be a parameter because we're changing it, and essentially I think I can have this trace exactly all the points that it goes through. All of these points that it goes through are on the same line. So here is the line described by all of those points. Okay. So what does that look like? Well, the x-coordinates start at x1, and then it's some multiple of v away. So when we multiply it by t, we get t times vector v, and that's going to be ta, tv, tb, and tc. And we're adding each of those to our x-coordinates, so x1 plus ta. Although typically we'll write them in the opposite order because a is staying the same and t is the parameter. So we'll typically write it like this. Now the y-coordinate is y1 plus a times t. I'm sorry, b times t, because we're adding bt. And then our z-coordinate is our original z-coordinate plus a scalar multiple of the z component. So this is our parametric form. The parametric form of a line is x equals x1 plus at, y equals y1 plus bt, z equals z1 plus ct, where x1, y1, z1 is any point on the line, and a, b, z is any parallel vector. So this is a point, and this, a, b, c, is a parallel vector. If you only write down one slide from the whole video, this is the slide to write down. So let's write the parametric form of this line. First, we want to find a parallel vector. So the parallel vector, we're going to do final minus initial, 8 minus 6, negative 4 minus 2, 11 minus 5, that will give us a parallel vector. 2, negative 6, and positive 6. Now, in order to write the parametric form, we're going to use, you pick a point. You want to make sure you use the same point for each of them. X equals 6 plus something. Y equals 2 plus something. Z equals 5 plus something. And those somethings are going to be a scalar multiple of this vector. So a scalar multiple of 2, a scalar multiple of negative 6, and a scalar multiple of 6. So this is the parametric form of that line.